All right, for example, here's a deuterium atom, okay? It's got a proton, neutron, and an electron, okay? Here's a helium atom. It has 2 protons, 2 neutrons, and 2 electrons. So fusing 2 deuteriums together will create a helium, which is still a heavier gas than hydrogen, but it's the same constituents. It's the same thing. It's made of the same thing. Protons, neutrons, and electrons. Everything is the same thing. And even these protons and neutrons are actually made of electrons because everything is an electrical charge. It's made of electrons. Everything in the universe is the electron. And let's say I fuse 3 of these together. I'll end up with lithium. Right, but wrong, okay? That's the concept, but here you have 2 orbitals. Deuterium only has 1 orbital, okay? So how can we compensate for that second orbital? So I basically fuse a deuterium with a helium. And it gives me 3 protons, 3 neutrons, and electrons. And that's going to give me an alkaline, okay? But if I want a crystal, I'm going to have to mix an alkaline with a gas. And depending on the gas constituents and the alkaline constituents, I'm going to get a crystal structure. Because the next thing, now you have beryllium, which is a metal, which is number 4. Now, how can I do this? Well, I need to mix deuterium, which is 1 in all 3, with lithium, which is 3 in itself. And the atom of deuterium with the atom of lithium will create beryllium. And I'm just throwing this out here, the 369, okay? You have lithium, which is 3, carbon, which is 6, and 9, which is fluorine or fluorite. Well, I'm getting ahead of myself. Let's do the 1, 2, 3. Hydrogen, helium, and lithium, the first 3 elements, 1, 2, and 3, equals 6, which is carbon. And if you fuse a hydrogen, a helium, and lithium together, you're going to get a carbon atom. Now, depending on the constituents, the next one would be boron, okay? Because it's crystalline form, but it's also a metalloid. So you have an in-between crystal metalloid kind of hybrid here, depending on the ratio of metal to gas, depending on which atoms you use. You see what I'm saying? Because everything's made of atoms, but all the atoms are different, but they're still made of the same exact constituents. And the mass of 1, 2, and 3 together would be 12.01, which is the mass of carbon, not to mention the protons, neutrons, and electrons of a carbon. So it's efficient enough to just lose just a little bit of energy when it fuses together. And some of these will lose a little bit more energy. It'll depend on the variant of atoms you use to combine to create which crystal and which lattice, essentially, which metalloid. But with the laws of thermodynamics, it's all still retained, okay, because it's all retained within the universe, okay? So everything that's emitted goes back to where it's coming from, which is space. It's a circle. Basically, in a nutshell, it's a recipe. It's an atomic recipe of how to make different elements with which atoms particularly to fuse together to make whatever other atom we want.
Well, the way the periodic table is laid out, the periodic table they have now,
Let's see.
it looks like a
Pull up
box.
the image of it.
It looks like a straight box.
Mm-hmm.
And they don't show the relationship that between every element, there's two
All right, here's the periodic table.
You'll see hydrogen sitting all the way over there by itself, but they don't show that hydrogen has the same tone as carbon.
What do you mean by tone?
Same tone, same key of E.
Talking about sound frequency, a harmonic
hertz. The
resonance.
next one would be like 81 hertz.
He's not crazy.
You go to silicon, it will double up and would be 162 hertz. You'll go to
He's touching,
to
basically, listen,
cobalt.
he's touching on dark matter, or dark matter, essentially. What it does is a sound frequency, just like we've seen many experiments, when you take frequencies and just run them through sand. Just little dots, which are sand. We live in a dot matrix. The universe is just a series of dots, and then when you zoom out further, all those little bitty one-dimensional dots make up a higher dimension. And then when you take those higher dimensions, they're all dots. And then you put all those together, you zoom out further, that's one thing. You zoom out and you see a bunch of those things, and then they zoom out further and make just one thing. So it's just an infinite higher dimensional universe that we live in. We live in a multiverse, but that multiverse shares the same space with the universe we live in. Therefore, the universe is a part of a multiverse, which is a part of something bigger, which is a part of something bigger. So even if we live in a multiverse, it's still only one gigantic universe. You see what I mean? So it's not that he's wrong. It's not that he's correct. It's that he's not explaining it. He's not able to specify in a simple, rational way in lay terms. So it's a dot matrix that we live in, and it's a composite. Everything is a composite of something smaller, and then it goes smaller, and then it goes smaller, or it goes bigger, 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 the macro and the microcosm. As above, so below. As within is without. That's space. Space is within and without everything, and it's static, okay? And that inherent trait of static infinites, which is unchanging, of space, which is within and without the universe, on the outside and the inside of it, means that it's going to lay that trait off on the universe, meaning inheriting traits is very important. He's going to touch on that too. The universe inherits static traits from space, okay? Because space is what incepted or ushered in or brought the universe into existence, okay? Create means just to bring something into existence. So when the universe was created, it created itself, space created it. People get hung up on the words and not how the words are actually associating with something, okay? You see what I mean? They get hung up on, oh, it created, somebody molded this or made that, or some god, imaginary wizard created a universe that it wasn't created. Dude, it exists. That means it was brought into existence. It means it exists. That's what create means, to bring something into existence. So people get hung up on words, but not the associations of the words, okay?
And it'll be 324 hertz. It's, in that base, if you were to take the angles of incidence or the tones that they create, their color. Like you can turn color back into sound based upon...
He's talking about color charge, just to elaborate.
Long or much longer. So all you have
to... Look, I think he sees something that's real, but he doesn't understand the science enough to be able to actually put it in the terms. Or he does, but he can't condense all of the information into a 3-hour video. And it's hard to do that when you have a lot of ground to cover.
Is keep dividing light by 2.
And when he's talking about this is squaring it, okay? This is not to mention, it's not the Fibonacci per se, it's the golden ratio. It's the spiral that is in everything. It's the vortex, essentially.
You keep dividing light by 2.
And the universe itself does never subtract, because the conservation of energy is always held. That means everything will divide or multiply. And that's why multiplication and division complement each other in an inverted way. Okay, to understand a product of division, you have to multiply. To understand a product of multiplication, you have to divide. They coincide. That's the conservation of energy, the first law of thermodynamics. Okay, it doesn't deviate from that. The universe is one particular weight, which is heavy. Okay, it's all the particles in the universe exist prior to the singularity, in a cold state before it condenses and gets really hot. But that same weight is there. It's just in a focal point. It's more dense in a smaller surface area. You see what I'm saying? If it's sparse and spread out, it's like a cloud. It's way, way, way diffused. You see what I'm saying? The particles at some point are ushered in. The lighter particles, like the electron, everything is distatic. It's electrostatic, okay? And the universe is actually it's an antiverse with a universe. It's basically all the antiparticles in the universe, like positrons, will merge with electrons, okay, on a very, very small fundamental scale through sound frequency, okay? It'll stick them together. And I touched on this on a couple of my videos. But what it does is it sticks these particles together. So the antiverse is what we can see. It's everything that is physical matter. The antiparticles are still there. They're entwined in a micro lattice on a quantum scale with the regular matter. And what it's doing is it's fluxing. Because as we take one particle and one particle, we touch the antimatter to the matter, boom, explodes. Okay, that explosion is just one particle and one particle. You have a whole clusteration of particles and you condense them together in this tight lattice because the universe is heavy and it's compressing everything that exists within it into a small micro quantum lattice. Okay, then all of this stuff is passing energy back and forth. It's fluxing, it's exploding, but it can't explode outward because everything's so heavy. So it's collapsing, exploding, collapsing, exploding. And it's doing this, and it's a flux. And what that flux is everything we can physically see. Okay? Now, this ties into the laser beams that the Greeks thought came out of our eyeballs. Now, our brain, like I'm just using him as an example. Here's the brain, okay? He's got eyeballs. Those eyeballs are connected to a living brain, which has synapse in it that is actually light. There is actually capacitance, light in our brain. Just like a capacitor would arc, our synapse do the same thing. They shoot electrons. There is literally light in our brain. Example, the nervous system can emit biophotons continuously. This is analogous to black body radiation. This is why an infrared light or a camera or infrared goggles would actually light you up because you're warm. You're emitting black body radiation, which are photons, which is light. So the brain is emitting light through the liquid in our eyeballs. And that liquid allows for light to be received. So our brain has to emit light in order to receive light. And that light collision is what we see. Okay, the light that's emitted from our brain through our eyeballs and the light that is coming from a star or this monitor or even the matter that I'm seeing, that frequency, that flux, is going to collide with the light that I'm emitting. And that collision is the vision that I have. That's what I'm seeing.
And you'll ultimately get back to the audible sound of it, because there was a relationship between light and color, sound and tone, matter and shape. I sent over Walter Russell's.
I was trying to get to that. That's what.
Yeah, it's Walter Russell's periodic table that he put together. Now you would compare that to what Mendeleev's periodic table. You'll compare Walter Russell's to it, and you'll see something completely different. It's unwinding.
Whoa.
It's unwinding. And you see there's a relationship that hydrogen.
So you had figured this out at a young age?
This right here actually coincides with inflation on a atomic scale, essentially. That's what he's trying to get at. Whenever he's talking about this expansion he's talking about, whenever everything is condensed, as anything cools, like ice, for example. Ice is a liquid. When it cools, it inflates. But it's solid then. It's in a lattice. So that he's talking about a lattice, a molecular lattice or an atomic lattice. And here's another example. When everything is fluid, okay? Glass. Whenever we find natural glass, it's in a particularly hexagonal lattice, perfect hexagonal lattice. When we melt it down and reform it into, say, a bottle, and then we look at the lattice again, it's completely discombobulated. It's screwed up. Because even if you let a bottle sit, this is why. If you let a bottle sit, okay, just on a table for 20 billion years, that glass is going to be a puddle. And it's not like it got hot or anything. It's that the micro on the lattice, the micro lattice of just the lattice of molecules and atoms that are stuck together in that on a micro scale are still moving in a fluid motion. Okay, they're still moving like water. Okay, but on our scale, when we look at it, we only see the steel bottle. So if we take that steel bottle or that glass bottle and we look down and zoom onto it, then we see a molecular lattice that if we could actually perceive the slow, like if we could take you know how we use slow motion photography? We film something that happens really slow with it's fast motion, but we'd actually be able to see the lattice move around. We would actually see its fluidity. Okay, and that's real. If you look up, now they say that the glass in church windows do this, and that's why some of it seems like the glass is still flowing over 400 or 500 years. They look like that, but that's still an underestimate. Okay, that's a colossal underestimate of time. It would take millions, if not billions, of years for the fluid, the glass, to just roll to the point where we can see it. It's like molasses, and molasses falls real slow and moves real slow. It's almost imperceptible, but it happens when we can use high-speed photography. That's what he's getting at.
This was all inside of that palace. I had access to it, and I knew the relationship.
You saw this in dreams.
I saw it as a circle. Everything was a full circle.
Everything goes back to where it's coming from.
Each area was just
the universe
expanding,
is a cycle,
a rag
water
around your
cycle.
hand. The first
plasmatic.
wrap, it's so tight. The very first wrap is so tight. That's the first one that Walter Russell did. Yeah, but go back to the wiggly one. This is how I saw it more so, but as a vortex. But
true,
you'll see there's a relationship between hydrogen, carbon, silicone.
I'm just going to throw this out here. Potential difference is the reason why a vortex is what it is. Like a tornado, a funnel, or a hurricane that has an eye. It's all potential difference of temperature. So the universe is thermonic. It's thermodynamic in nature. And that's why you cannot throw out the laws of thermodynamics when it comes to quantum mechanics. You cannot. The quantum mechanics apply to potential differences as fluxes or quantum fluctuations. These potential differences create vortices Okay, so it's a tussle. You got hot or cold, a potential difference, and they want to merge, but they can't because they keep dancing around each other. They're trying to get into equilibrium with each other, but they can't because they're too different. And that's why you have polarities. Okay, and he'll touch on that here in a little bit too, and I'll explain why he's talking about with two stars when they're emitting, and those polarities and the particle collider. I'll explain how that coincides.
Cobalt, rhodium, they're all bonded. They're all sit as the middle point between two noble gases. So those things don't really exist. It's only one substance. Now the problem is, the first thing that we're able to perceive is hydrogen. That's the first visible element.
Because it's the oldest and simplest.
Before it is too
But
dense
everything is made of hydrogen.
for us to perceive it.
Every atom on
every
atom, like I said, every atom on the periodic table is made of hydrogen. Because they're made of the same substance, like he was talking about, protons, neutrons, electrons.
But as you reach into the next octave, the carbon octave, and they call that a bisexual tone, because the carbon has two tones to it. It has a negative side and a positive side.
Okay, now he's talking about polarity. And whenever he talks about harmonics, when he's talking about like you play an opposite tone, you'll have it contracting, whereas you play the one opposing it, it'll retract. You have an influx and an outflux, okay? There's an input and output to everything, and this is the conservation of energy. And whenever you play a frequency, like I said, with the sand, we can see the sand dance around with different frequencies. If you play an opposing frequency, instead of it collapsing inward to make a geometric shape, it's going to expand outward to make a geometric shape. See what I'm saying? So when he touches on that, you'll understand where that's coming from.
Part where lithium behaves. Lithium is contractive. Beryllium is contractive. Boron is contractive. But the moment you get to carbon, you balance it out.
I'm also going to go explain something. When he says the contractive force is male and the retractive force or the expulsion force is female, then he has those backwards, okay? The male explodes or squirts or ejaculates, essentially. And he'll touch on that when it comes to a star basically taking a crap, okay? That's the spew outward, okay? A woman actually has contractions when she goes into labor. So he's touching on Taoism or the binary universe in that aspect, because there is everything that is input is output, okay? And that's why you have either a whole or a solid. This is why the universe, space itself is like a womb that harbors the fractal universe. And the universe is male, that it ties to the light, the sun, or a sun, which is a male, alpha, nuclear DNA, male. It all ties together through fundamentals, okay? And the letters tie to the fundamentals, which tie to numbers. So you have to understand a fundamental backbone to be able to understand the numbers or where the numbers go. But it can be done. And that's the equation that he was talking about. There's a grand unified theory prior to the singularity that helps form the singularity. Then after the singularity is the Big Bang, and that's when our math starts. But that's when we have numbers. You can't calculate numbers prior to there being numbers. You have to calculate all the data that we have from the universe that we know, understand the fundamental backbone of it back here. And then once we understand the fundamental backbone, we'll be able to take the numbers and put it here. The number, put it here. Number, put it here. But without those fundamentals, we're working blind. And you've probably heard that. We're flying blind. And you've heard Neil deGrasse Tyson probably say that, because he has.
To a perfect balance of plus and minus 4. So it's a double tone. Then nitrogen is minus 3,1. Minus 3. Oxygen is minus 2. Fluorine is minus 1. Now the balance of this, all of those are mates. Fluorine and lithium naturally mate. If you have lithium bonded with any other element, the moment that fluorine is introduced,
yes,
it will break all bonds.
Okay, so right here he's talking about lithium, okay? It has a 0.98 electronegativity. Okay, fluorine has 3.98 with a potential difference of 3.0, okay? This means that the affinity for electrons in the fluorine is greatly higher than the affinity of electrons in lithium. But lithium can take more electrons in than it expels, okay? So this is actually a way to create a solid state radioisotope thermoelectric capacitor. I know it sounds crazy, okay? But you need that potential difference, okay? And the 369 ties in here. You need radium, which is 0.9, okay? And the lithium is 0.98. That's a potential difference of 0.08, okay? That's going to be your positive, okay? That's going to be your potential difference in a chain from radium to lithium, okay? Where your energy is going to go into your lithium from your radium. That's your decay product. Then you're going to have from the lithium to the fluorine, which is a 3.0 potential difference. So you have your positive, which is 0.08. You have your negative, which is 3.0. Then you're going to have your carbon to gold chain reaction, which is 2.54. This is your precision resistance. So you have your positive, your negative, and your resistance. In a thermoelectric, it's a thermal electric generator, okay? It uses solid state physics. So your radium is your power source. The lithium is going to absorb the energy or wants the energy from the radium. That energy is condensed in the lithium, which is expanded into the fluorine. Now your carbon acts as a dielectric and an insulator, okay? And your carbon is going to act as a conductor on the outside. Look, just imagine your radium is the pit. This is like uranium in a nuclear bomb. It's the pit. It's the energy source. It's the power source. You have plate 1 of a capacitor, which is lithium. You have carbon, which is the dielectric in between plate 1, and then you have plate 2, which is the fluorine. So you have the lithium gaining the energy from the radium. This is passed through the dielectric, like a capacitor would work, which is a carbon dielectric, into the fluorine because it has an affinity for electrons, okay? You have the carbon, which is a type of dielectric and an insulator also with gold, which is catalytic, and it's also a good conductor of electrons, okay? So this would, believe it or not, be, this right here where I'm seeing, this is the Ark of the Covenant, believe it or not, okay? The thermonuclear arc between the cathode and anode is plasma, and it's set in the king's chamber, all right? Now look, here's the cathode, here's the anode, or the cathode and anode, okay? You have the pit, which would be the radium. Now, this right here is actually hieroglyphs. This is actually on hieroglyphs, and it's Aaron's rods, okay? Aaron's rods were in the Ark of the Covenant. We use nuclear rods in a nuclear reactor. This is a solid-state nuclear reactor. This right here would be analogous to the P-type and N-type material, okay? So your lithium is your P-type, and your fluorine is your N-type material.